Alright, so on number 2, when we need to, it says analyze the following functions or behavior after sketching a graph and draw and label the asymptotes. So the first thing you should do is go to y equals and type the function in. So y equals, so 5 times 1.5 raised to the x, and then plus 2. And then what I'm going to do is I'm going to go ahead and go to the table, second table. So what I notice is, let's see, the farthest we go on here is -8, so let me just go ahead and start there. So -8 says 2.19, so I'm thinking somewhere like right there. At -7 we're at 2.29, so like remember that's 3, so we're barely above the line. -6 we're at 2.5, so somewhere like there. At -5 we're at 2.6, so still about half. And then at -4 we're at about 30. And at -3 we're at 3.5. So somewhere in there. And then at -2 we're at 4.2, so there's 5, so 4.2 is like right above it. And then at -1 we're at 5.3, so there's 5, so 5.3 is like right in there. At 0 we're at 7 exactly. At 1 we're at 9.5, so here's 9, so there's 9.5. At 2 we're at 13.25, so 13 a little. And then 18, almost 19, so almost 19. And then 27.3, so 27 is like right there, so 0.3 is just a little bit above it, and there we go. Okay, so I do need to connect them. And what I noticed on the left-hand side is that it got closer and closer to 2, but it shouldn't actually reach it. So I just kind of drew it along those points. And that's okay if your points end up being basically on 2. But it did say to draw and label the asymptote. So you do need to, on the test, draw your dotted line. Now, it's okay if you don't label it necessarily on the graph because you have to write it down what it is down here. But I'm going to go ahead and write that this is a horizontal asymptote at y equals, because we go through the y-axis, at 2. And I know that from that number right there. Okay? So I will expect you to plot all the points that you're able to see on the graph. So I don't know that I'll make it have that many points, but I will. You will have to graph them. So growth or decay, well, it goes up. It's growth. And I can also tell that right here. So remember in your exponential functions, you've got a times 1 plus or minus r to the x plus b, if you have a vertical shift. R is how far away the base is from 1. And so this right here is 1.5, which means it's 5 times 1 plus, which means growth, 0.5 to the x plus 2. So this is my r. So my growth rate is 0.5 or 50%. Okay? Now, as far as domain goes, domain is left to right, and the function is defined all the way from negative infinity to positive infinity. It goes left, it goes right. So we can say all real numbers or negative infinity to positive infinity. And then the range is low to high. The lowest it goes is 2, but we never reach it, so parentheses, and then it goes up to infinity. Okay? The end behavior. End behavior says, or asks you where the function is going. So it's saying, as x goes to negative infinity, meaning as the function goes to the left, where is y going? So as you go to the left, the function is approaching 2. And as you go to the right, when x goes to positive infinity, the function is going up to positive infinity. So that's my end behavior. As far as the x-intercept goes, we're trying to find where it crosses the x-axis, and this never does. Because of the horizontal asymptote, it never goes past it, so we have no x-intercept. Now the y-intercept is where it crosses the y-axis. And looking at the table, I know that when x equals 0, y equals 7. So that is the point 0, 7. And my horizontal asymptote is the y equals 2. You've got to remember the y equals. It's very important. Okay? If you don't have the y equals, then you're not liable to get all the points. And then on the average rate of change, remember, we're basically finding the slope between the point at 0 and the point at 3, right here. So we're finding the slope between these 2 points. So really what you need to know is the formula for slope. y2 minus y1 over x2 minus x1. And you need to know these are two x values, x1 and x2. So x1 is 0, x2 is 3, y1 is what I get when I plug in 0, which is 7. And then at 3, the table tells me, it just disappeared, 18.875, which is y2. So the formula says y2, 18.875, minus y1, which is 7, over x2 minus x1, 3 minus 0. So if you type that in, you can do it separately, 18.875 minus 7, and then you notice it's divided by 3, so you can do that. Or you can do it all in one time and do alpha y equals, and press enter. 18.875 minus 7 divided by 3 minus 0, and there you go. And remember, I like 3 decimals, so 3.958. Okay? Next we're going to do number 4. So number 4 says $900 is invested in a money market account that earns 1% interest annually. How much money will the account be worth after 12 years, after 20 years? So in my money account, my money formulas, I've got amount equals principal times 1 plus r to the t. I've got amount equals principal times 1 plus r over k to the kt. And I've got amount equals principal times e to the rt. I messed up on that. This is annually, k times a year, and continuously. So for the first one, it just says annually, and it doesn't tell me anything about compounding other than the interest being annual. So we're going to go ahead and assume it's compounding annually, which means I use the first formula. So I would write, in general, just the formula, amount equals 900 times 1 plus the interest rate, which is 1%, so 0.01 to the t. And that's my formula in general. Now if I want to know 12 years, then I would type in my calculator, 900 times 1 plus 0.01 to the 12th, and then 900 times 1 plus 0.01 to the 20th, and find those amounts. So 900 times 1 plus 0.01, or 1.01, raised to the 12th. And I get, this is money, so we'll go 2 decimals, $1,014.14. And if I want to change that to 20 years, then it's 20. And I get $1,098.17. Okay. What if the interest is compounded monthly? Well, monthly means k times a year, 12 times a year. We're talking about the middle formula. So that would be amount equals 900 times 1 plus r, which is 0.01, over k, which is 12 raised to the 12t. So in order to figure out the amount in the account after 12 years, I would just replace t with a 12. So let's do that. 900 times 1 plus 0.01 divided by 12 raised to the 12 times the number of years, 12. So that is $1,014 and if we round 70 cents. And then after 20 years, so I just changed that to a 20. So 12 times 20 years, not 12 times 12. And that is $99.17. Okay. And then compounded continuously is the PERT formula. So that would be amount equals principal. $900 times e to the r, which is 0.01 times t. So if I want to know how much the account will be worth after 12 years, I just say 900. And then e, don't forget the e is above ln right here, or above the division symbol right there. I prefer to use this one because it already raises it to power. So 900e raised to the 0.01 times 12. And I've got, for 12 years, $1,014.75 if I round. And then for 20 years, I get $1,099.26. So there's not a whole lot of difference when your interest rate is only 1%. And it's such a small amount of money. If you got larger amounts of money, then 1% would be a bigger deal. But with a smaller amount of money, a larger percent would still do better. But anyway, so there you go. Okay, number 6. A certain type of bacteria can double every 3 hours. So when I think about that, I know that to double means to multiply by 2. So if it says something can double, then I know that my initial amount times my rate, well, not my rate. I don't want to do the 1 plus, but it is 1 plus, but in fact it's 1 plus 1 because you're adding 100%. If you want to double something, you've got 100% plus another 100%. That's 200%, which is exactly double. But if you think about it, when you're doubling something, you're just multiplying it by 2. So what you can say is, okay, write an equation representing this information and use it to determine how long it will take until there are 10,000 bacteria if there are 4 present to start with. So the initial amount is 4. Doubling means I multiply it by 2, and I raise it to the, well, if it just said every hour, I would say to the x. But it says every 3 hours, so I have to divide that number of hours by 3. So do you see how, if I plug in, well, let me just show you. So 4 times 2 raised to the x divided by 3. Okay. What should happen is I should start out with 4 at time 0. And then by the time, so 1, 2, by the time I get to 3 hours, I should double and have 8. 4, 5, 6. By the time I get to 6, I should have 16, and I should have doubled again. So if I go to my table, I see that at 0, I'm at 4. And then I'm still increasing, but I don't double, get all the way to double until I get to 3. And then I get at 6, I'm at 16, and then it would keep on going. So at 9, it should be at 32, and then 64 at 12. And there you go. So I'm doubling every 3 hours. So I'm still increasing, but I don't reach a full double until I get to 3 hours later. So the question is, how long will it take, how many hours, what does x equal, in order for this to equal 10,000 bacteria? So what I want to do is I want to graph. So go to y equals and I type in that, and then on y2 I type in 10,000. And it doesn't matter which one you put in y1, which one you put in y2. And I go to my window and I think about what those represent. So x represents hours, so I'm going to go ahead and go 0 to, we'll try 30, and if it's not good enough, I'll fix it. And then I need to be at least be able to see 10,000, so I'll go 15,000, or you could do 11,000, whatever you want to do. And I press graph. So, okay, 30 years is not quite enough, so I'll go ahead and go in 50 years. So I'm pretty sure 50 is fine. Yep. Okay, so we go second, calculate the intersection, and then my blinky dude's right there if you can see him, but you really don't need to move him. You can just say first curve, he's on one of them, then he bumps to the second one, you press enter, twice, and then you press enter a third time on guess because you don't want to guess. You don't need to, and it tells you 33.863, and don't forget that this is hours. Okay. If $10,000 is invested at 3.26% interest in a compounded continuously account, and it is worth $16,440.29 when the account is closed. How many years did it accrue interest? Basically, how long was the account open? So I know that I've got $10,000 in a compounded contingency, which means PERT. So e to the r, which is 0.0326, times time, and that's what I'm trying to find. And I want to know how much time does it take for this to equal $16,440.29. So this is another y equals and find the intersection situation. So 10,000 times e raised to the 0.0326 x, and I want to know when that equals 16440.29. And as far as this goes, I need to be able to see 16,000 and a half, so I'm going to go 20,000. And time is 50 years, and so that's more than enough. So, okay. Second, calculate number 5. Enter, enter, enter. And I get 15.249999, so 25 years. 15 and a quarter years. Okay? Now, you guys didn't ask me to, but I wanted to go ahead and go over 14, 16, and 18. Just to kind of make sure, because we'd done all the odds over here, but we really didn't address what happens here. So log base 49 of 7. What I want to do, see here I wanted to be able to rewrite 64 as 4 to some power. 64 is 4 cubed, so the answer is 3, right? Well, I want to be able to rewrite 7 as 49 to some power. So this is log base 49 of 49 to the 1/2 power. 7 is the square root of 49, which is 49 to the 1/2 power. So my answer is 1/2. Okay? So log base 64 of 4 is log base 64 of 64. Well, 4 is the cubed root of 64, because 4 cubed equals 64. So that using the power chart, so that 4 is the cubed root of 64, which means it's 64 to the 1/3 power. So the answer is 1/3. And then this last one, on your power chart, you'll notice that 1 is 7 to the 0 power. So the answer is 0. Okay? So you're always trying to rewrite this as the base raised to some power. Okay, let's go to number, not on that page, number 30. Alright, so this really should say a sub n equals 3 times a sub n minus 1, but order on that doesn't really matter. Okay, so in the recursive formula, you got to remember that the recursive formula has the common ratio right here, and then the first term right there. So it says find the explicit formula. So the explicit formula is a sub n equals a sub 1 times r to the n minus 1. So in this case, a sub n equals a sub 1, which is 4, times r, which is 3, raised to the n minus 1. So there's part of my answer. It says find the first 5 terms. So 1, 2, 3, 4, 5. The first term is 4, and then I'm multiplying by 3. So 4 times 3 times 3 times 3 is 108 times 3 is 324. So there's my first 5 terms. And then it says find the term named in the problem. I need to find the 10th term, so I'm going to use that right there. A sub 10 is 4 times 3 to the 10 minus 1, which is just 4 times 3 to the 9th, not 12 to the 9th, 4 times 3 to the 9th. The only thing being raised to that power is 3. So it is 4 times 3 to the 9th power, which is 78732. I have a lot of people that would multiply 4 times 3 and say 12 to the 9th power, and that's a lot larger, and it's not the answer. Okay, so number 32. Given the two terms in the geometric sequence, find the explicit formula and the term named in the problem. So they're giving me the fourth and the third term, so I'm going to go ahead and draw that out. 1, 2, 3, 4. A sub 3 is 27. A sub 4 is 81. So remember, anytime you want to find the common ratio, you divide the any term by the previous term. So I'm going to divide 81 by 27. 81 divided by 27 is 3. So my common ratio is 3. Okay. Well, that means in solving the formula, a sub n, or writing the explicit formula, a sub n equals a sub 1 times the common ratio, which is 3 to the n minus 1. So what I don't know is the first term. Okay. So there's the actual working it out way, and then there's just like thinking it out. So if I multiply by 3 going this direction, that means going this direction, I divide by 3. So I'm just going to take 27 divided by 3, and I get 9. And then I'm going to divide that by 3 and get 3. And that is my first term. So a sub n equals a sub 1, which is 3, times 3 to the n minus 1. You can also work it out, but just dividing as you go backwards is perfectly fine with me. Okay. On number 34, I'm given the third and the ninth. So 1, 2, 3, 2, 9, 1, 6, 4, 5, 6, 7, 8, 9. 256. I need to find the explicit formula and the sixth term, and I think when I worked it out on the board I forgot the sixth term. So, oops. Okay, what I'm going to do is I'm going to pretend like that's the first, which makes this the second, third, fourth, fifth, sixth, seventh. This is the seventh term. So we set up the formula. A sub n equals a sub 1 times r to the n minus 1. A sub 7, which is, in our case, 256, equals a sub 1, which is 2916, times r to the n minus 1, and that is 7 minus 1. Where are we getting this? Sorry, guys. Got distracted. To the 7 minus 1, so basically the sixth power. Okay, so what I'm going to do is divide by 2916. And I'll do r to the sixth. And then I want to solve for r, so I take the sixth root of both sides. So you can work that multiple ways. You can either you can type in 6 and do math number 5, and it puts it in there. Or you can just type in math 5, and then it'll put the answer up there, so you just say, okay, I want 6 up there. And then type in 256 divided by 2916. Or you can just raise the quotient to the 1/6 power. Either way, 1/6 and the 6th are the same thing. So basically you get 0.6 repeating, which is 2/3. Wonder if it'll do it for me. Yeah, okay. So my common ratio is 2/3. So if I go forwards, I can go 2916 times 2/3, and that would give me this one, 1944. If I times by 2/3 again, I get 1296, 864, 576, 384, and 256, so that's good. And then if I want to go backwards, then instead of multiplying, then I would divide. So I could say 2916 divided by 2/3, or multiply by 3/2, and that is 4374, and then do that again, divided by 2/3, and I get 6561. Okay. That is the way to just like figure out the first term, working it that way. Let me show you another way. If I know a sub n equals, I don't know the first term, or I didn't, times r to the, which is 2/3 to the n minus 1, I can say, okay, a sub 3 is 2916, which means you can see that. Okay. A sub 3 is 2916, so that's a sub 1, which I don't know, times 2/3 to the 3 minus 1, which is just 2. So basically I would just divide by 2/3 squared. And let's see if we get it. 2916 divided by 2/3 squared. And I get 6561, which is the first term that we figured out. So I know that in general, the whole equation is a sub n equals a sub 1, 6561 times the common ratio, 2/3 to the n minus 1. Now it does say find the sixth term, and I already did that just by doing it right here. So 4, 5, 6. That is a sub 6. Alright. Numbers 45 and 48. Okay. So 45 says g of k, and I know g of x equals negative 2x squared, and k of x equals x squared plus 2x. So when it says find g of k, I know that g is the outside function, and k is the inside function. So what I'm going to do is start writing the outside function g, negative 2, but instead of x, remember replacing x with k of x, instead of x, I put k of x in there, which is x squared plus 2x. Now when I work this problem, I've got to remember that I'm actually saying negative 2 times x squared plus 2x times x squared plus 2x. Because these are, you cannot distribute the power, and you cannot distribute the negative 2 until after you've distributed. So let's distribute. I've got x squared times x squared, which is x to the 4th. Bring down the negative 2. And then I've got x squared times 2x, that is 2x cubed. I've got 2x times x squared, which is 2x cubed. And I've got 2x times 2x, which is plus 4x squared. The only thing I can combine are the middle two terms. So these two combine to 4x cubed, because I'm just adding them. 2 of them plus another 2 of them is 4 of them. And now I distribute the negative 2. So I've got negative 2x to the 4th minus 8x cubed minus 8x squared. And there we go. Okay. Number 48 says g of h of g of x. So g of x is negative 2x squared. H of x is the square root of x plus 7. And that's all I need. Okay. So I've got g of h of g of x. Okay, so I'm going to figure out the middle h of g of x first. So h of g of x is, h of x is the square root of something, because it's x, plus 7. And in place of x, in h, I'm going to put g, because g is inside h. So I'll put negative 2x squared. which, I mean, there's nothing happening to that. Okay, you cannot simplify the square root in that square because you're adding stuff. I've got a lot of people that try to say, hey, I've got the square root of 9 plus 5, that's 3 square roots of 5, to which I'm saying, no, it's not. Because 3 is the square root of 9, and that's the square root of 45, and the square root of 45 is not the square root of 14, which is what this is. Okay? No. Because of this addition and subtraction, I cannot just square root whatever has a perfect square. So this right here is only the square root of negative 2x squared plus 7, and I'm done with that. Now, I now need to find g of this inner thing. So g is the outside function, this, negative 2 times something squared, and that something, this, is this. So, the square root of negative 2x squared plus 7. I notice that the square and the square root cancel each other out. So I'm left with negative 2 times negative 2x squared plus 7, which is positive 4x squared minus 14. And there you go. Good luck studying, guys.